Hey guys, welcome to On the Spot STEM, and today we're going to be doing AMC8 2018 problem 24. So this problem says, in the cube ABCDEFGH with opposite vertices C and E, J and I are the midpoints of the edges FB and HD respectively. Let R be the ratio of the area of the cross-section EJCI to the area of one of the faces of the cube. What is R squared? So for the sake of simplicity, since it doesn't give us any side lengths, let's just let CD equal 1. So let's just draw that on our diagram here. So since CD equals 1, that means that since I is a midpoint of side HD, and HD also has length 1 because it's a cube, that means that ID equals 1/2. So you can see here by the Pythagorean theorem, since CDI is a triangle with a right angle at D, CI is just equal to the square root of 1 squared plus 1/2 squared. And that is just equal to root 5 over 2. So now we have that CI is root 5 over 2. Now we can do a similar argument for EI because EH is equal to 1 and HI is equal to 1/2. So that means EI is also equal to root 5 over 2. EJ is also equal to root 5 over 2. And CJ is also equal to root 5 over 2. So since all four side lengths of the quadrilateral we're trying to find are equal, that means that EJCI is just a rhombus. And in a rhombus, the area is just 1/2 the product of the diagonals. So let's just calculate the lengths of all the diagonals. So EC, that's just the space diagonal of the cube. So that means that EC is root 3. Now JI. JI is just a diagonal of a square. So JI is equal to root 2. So now, if we multiply all of this together, we just get the area is 1/2 times root 3 times root 2. And if we simplify, we get that this is root 6 over 2. So that's the area of EJCI. Now we want to find the area of one of the faces of the cube. But that's simply just 1 squared, which is equal to 1. So that means that R is just equal to root 6 over 2. So now we just square R, and we get R squared is equal to 6 over 4, which is equal to 3 over 2. And we look back at the answer choices, and we see that 3 over 2 is an answer, so that means the answer is just C, and we're done.